Okay, this is the second one, and this is calculating the net present value for each of the products. So here again, I have product A and product B. This is the purchase of the equipment. It's the same 170,000 and the 380,000. Now I've got it in the parentheses because I actually have to pay this. Whereas the sales that are going to come in less the variable and fixed out-of-pocket expenses are outlays. Okay, so that's the net cash inflow. This is no different than what we had calculated up here, just so that you know we're talking about the same thing. Okay, so there are my net cash outflows, or excuse me, cash inflows. So here's the deal. The 170,000 that I'm going to spend on the equipment today in today's dollars is $170,000. That is that's no mystery. Okay, so the $60,000 that are our cash inflows over the next 5 years is where we're going to need to use a discount rate. Why? Because I don't get that 60,000 all at once today. I have to actually put it into today's dollars to figure out what $60,000 in payments over the next 5 years is going to be in today's dollars. So I hope that all makes sense. All right, so how am I going to do that? So I'm going to take I'm going to find in my annuity table. Why am I going to my annuity table? Because this is an annual $60,000. It's not a one-time shot. It's every year for the next 5 years. I just have to figure out what that means in today's dollars, okay? So that is why I'm going to head over to my annuity table, which is this table right here. And I'm going to look down at the 5, so periods will be 5. Why? Because it's 5 years. Why? Because that's what the problem said. And then I look over to the 16%. Now I don't think you can see my mouse moving around, but I'm at the row 5, column 16, and at that intersection there's the number 3.274. That number doesn't have to mean a lot to you. That's just the discount rate that's been factored. If you want to get really fancy, this 1 over R formula is how that number is derived, but I think you'll just be happy to know that it's 3.274. So I'm going to take that 3.274 and plop that over here, and I multiply that times the 60,000 to come up with a present value of $60,000 over the next 5 years. In today's dollars means that that's $196,440. Okay, which is less than $60,000 times 5, which would be $300,000, because again, I have to wait for 1 year, then 2 years, then 3 years, and and so on and so forth to get that money. So that's why I'm trying to discount that into today's dollars. All right, so then to come up with the net present value, I simply take that 196,440 less the cash outlay that I had to do to get that $60,000 a year for the next 5 years, which is $170,000. So my net present value is just the difference, otherwise known as $26,440. I'll repeat that same process for product B. So here you can see I have a cash outlay of $380,000, and then I have a net cash inflow of $130,000 a year, and my discount factor is still that same 3.27, and I'll multiply that times the 130 to come up with $425,620. So the net present value of spending $380,000 today and getting $130,000 over the next 5 years gives me a net present value of $45,620. Phew! Okay, so, and I highlighted that one because I'd rather have $45,000 rather than $26,000, and I think you'd agree.